Good morning. So in previous class we were discussing molecular orbital theory. Okay. So it is molecular orbital theory. And this theory is also known as band theory. This theory is also known as band theory. Okay. So I told you the basics of molecular orbital theory. Okay. And this band theory is just an extension of molecular orbital theory. Okay, this band theory is an extension of molecular orbital theory, MOT. Okay, so I told you, if two atomic orbital combines together, then two molecular orbitals are formed. Okay, we are taking example of lithium. Okay, lithium is a metal and we are taking example of lithium atoms. Lithium atoms, since lithium is a metal, so lithium atoms are binded by metallic bond. Okay, and we are just going to define or explain metallic bond on the basis of molecular orbital theory. So it is band theory, okay, is an extension of molecular orbital theory. And then we will say I am taking example of lithium. Okay, so two lithium, okay, lithium, it is lithium, then atomic number of lithium is 3, then its configuration will be 1s2 2s1. Okay, so if this 2s1 of one lithium is combining with 2s1 with other lithium, mean like this, lithium Li2. Lithium means Li2 molecule. I am taking Li2 molecule, and it will be like lithium 1 electron, since it is 2s1, plus 1 electron, again it is 2s1, it belongs to lithium atom. Okay, so two lithium atoms are combining. Okay, and their outermost, I am showing their combination of their outermost atomic orbital. So these two lithium atom, okay, will form two molecular orbital. As I have told you, okay, number of molecular orbital formed is equal to number of atomic orbital combined. Okay, so we will say this will give birth to two molecular orbital, one molecular orbital is at higher energy level and other molecular orbital will be at lower energy level. Okay, so energy level of this is, okay, and I am giving you example of Li2 molecule. This is Li2 molecule. Okay, so this is here 2s1 na, so it will be sigma 2s, it is sigma 2s, and I told you anti-bonding molecular orbital are represented by star. So this one is sigma star 2s and this one is sigma 2s. Okay, and 1 electron, 2 electron will be formed here. So sigma 2s2. Okay, this is bonding molecular orbital anti-bonding molecular orbital A BMO, anti-bonding molecular orbital, and this one is bonding molecular orbital, BMO. Got it? So this is in case of Li2 molecule. Now, if there are 3 molecules of lithium combining together, then if 3 atomic orbital will combine together, then molecular orbital formed will be 3. Okay, we will take example of Li3 molecule, and I am going to rub this. I am taking example of Li3 molecule. So what will happen in Li3 molecule? 3 atomic orbital will combine. This is first atomic orbital, this is second atomic orbital, and this is third atomic orbital. Okay, this one is 2s1, again this one is 2s1, 2s1, one electron is filled, one electron is filled, one electron is filled. Okay, so it will give rise or give birth to 3 molecular orbitals in the way 1, 2, and 3. Okay, so energy level are okay, then this is energy level of bonding, and this one is energy level of anti-bonding. Okay, means okay, so I told you 3 atomic orbitals are participating here, okay, to form 3 molecular orbital. So this one is known as bonding molecular orbital, which have least energy, bonding mood. Sorry for the disturbance. Okay, so we were discussing 3 atomic orbital of lithium is participating to form 3 molecular orbital. Okay, so first with least energy is known as molecular bonding molecular orbital, then this is known as anti-bonding molecular orbital, anti-bonding molecular orbital, and this is known as non-bonding molecular orbital. Non-bonding molecular orbital. Okay, getting this? Okay, so I told you this is in case of Li3 molecule. This is in case of Li3 molecule. Okay, and what will happen in this case? 2 electron will occupy the bonding molecular orbital, 1 electron will occupy non-bonding molecular orbital. Okay, and this will remain empty. So we can say here this is Li3 molecule. This is Li3 molecule. So in Li3 molecule we will say 3 atomic orbital combines in Li3, 3 atomic orbitals, 3 2s atomic orbital, combines to form 3 molecular orbital that is bonding molecular orbital BMO, anti-bonding molecular orbital ABMO, okay, and non-bonding molecular orbital, say it is NBMO. Got this? So 3 atomic orbitals combine together to form 3 molecular orbitals, okay, and these are 3 2s atomic orbitals, okay, of lithium atom. So 3 atomic orbital combines, then 3 molecular orbital will be formed, okay, and one will be bonding molecular orbital, then anti-bonding molecular orbital, and non-bonding molecular orbital, okay. So important discussion is the non-bonding molecular orbital, the non-bonding molecular orbital have exactly the same energy, okay, as the participating atomic orbitals. Getting this? I told you this non-bonding atomic orbital have exactly the same energy, okay, as the participating atomic orbital. So this is energy level of participating orbitals, and you can see here this energy level, okay, means in case of non-bonding molecular orbital, this energy level is same, you can check, okay, but in case of anti-bonding, this energy level is placed higher. This is the difference between energy. And in case of bonding molecular orbital, the energy level is shifted below. This is the energy level difference. So I told you energy level of non-bonding molecular orbital is exactly the same, okay, of bonding molecular orbital, okay. And one more thing, this non-bonding molecular orbital, the non-bonding molecular orbital, I am writing it NBMO, non-bonding molecular orbital, okay. The non-bonding molecular orbital have no contribution in the energy state of molecule. Okay, so this is example of Li3 molecule. Now come to Li4 molecule. Okay, now come to Li4 molecule. Okay, so if 4 atomic orbitals of lithium will be combining, then according to molecular orbital theory, 4 molecular orbital will be formed. Okay, so take here 4 atomic orbitals of lithium. So example is Li4. Li4 means 4 atomic orbital of lithium are combining now. So say this is first, second, third, and say this is fourth. Okay, all these are 2s1, 2s1, 2s1 and 2s1. So every orbital is having 1 electron. So what will happen? 4 atomic orbital is present, means 4 molecular orbital will be formed. So 2 will be bonding and 2 will be anti-bonding. So this is one anti-bonding, other anti-bonding, this is bonding, and this is anti-bonding, sorry, bonding. Okay. Okay, so energy level I am just writing. This is energy level of the atomic orbitals. Okay, these are energy level of the anti-bonding, and these are energy level of the molecular bonding molecular orbital. Okay, so it is forming two anti-bonding ABMO, two anti-bonding molecular orbital, and two bonding molecular orbital. So 4 electrons will be present in the bonding molecular orbital as 1 electron, 2 electron, 3 electron, 4 electron. Getting this? So this is in case of Li4. Now we are discussing metallic bond. Okay, so in a metal there are, we say, infinite number of atoms present. In a metal there are infinite number of atoms present. Okay, so if n number of atoms are combining together, then the molecular orbital formed will be n molecular orbital. Getting this? So if n molecular orbitals, I am writing here, if n molecular orbitals if n atomic orbital of lithium metal is combining together, then n molecular orbital will be formed. N molecular orbital will be formed. Okay, so this is example of LIN, means this time n number of atomic orbital have participate, LIN. So in this case lithium, okay, and say this is 2s1 of lithium, so one atomic orbital, this is 2s1. Since it is LIN means n okay, means we say n, it is say Li1, Li2, Li3, so it will be Lin. So n atomic orbitals of lithium are participating, okay, this time to form n molecular orbitals. So molecular orbital formed, okay, will be n in number, means we say molecular orbital will be like this. and this will be n molecular orbitals, n molecular orbitals of different energy. Getting this? So right here, if n atomic orbital will participate to form n molecular orbital, okay, then the molecular orbital MO, writing right here molecular orbital, then molecular orbital, or then the energy difference of these molecular orbital MO orbital, okay. If n atomic orbital will participate to form n molecular orbital, then the energy difference of this molecular orbital will be so small that this will begin to blur. And due to this will not give a distinct view. Just try to understand this, okay. I have written, if n atomic orbital will participate, okay, to form n molecular orbital means so many molecular orbital are there, okay, 1 2 3 4, okay, means like this. Say this is 1 2 3 up to n, okay. These are molecular orbital formed, okay. So n molecular orbital will be formed, okay. And we know molecular orbital consists of bonding and anti-bonding, molecular orbital, and the difference between their energies are not means if there are so many molecular orbitals, then the differences between, okay, the molecular orbitals will be less, and if the difference will be less, then what will happen? They will okay, so it will look like this and not this, because it has begun to blur. So you are not going to get a distinct view. You are going to view this like in this diagram, okay. So we will further write the outcome of this will be multiple layer band Okay, multiple layer band means now this will look like as band, as band. Okay, so we will write, in case of lithium, okay, if 2s each atomic orbital is combining, then 2s have one electron present. Okay, and we know the molecular orbital formed will be bonding and antibonding, bonding and antibonding. Means we will say here one layer of, okay, these are layers of the band, these are layers of the band, layers of the band. Okay, since I told you these are band, so these are layers of the band. So each layer can accommodate 2 electrons. Each layer can accommodate 2 electrons. So this layer can accommodate 2 electrons, this layer can accommodate 2 electrons. Every layer is capable of accommodating 2 electrons. So right here, each layer present in the band, each layer present in the band is capable of accommodating 2 electrons with opposite spin, Getting this? Each layer, okay, in the band is capable of accommodating 2 electrons with opposite spin. Okay, this you have studied in class 11th, spin. Okay, now come back to lithium. Okay, lithium, we know, I told you it is 2s1 atomic orbitals are combining, so 1 electron is present in 2s. Okay, and I told you one layer can accommodate 2 electron. Okay, one layer can accommodate 2 electron, and these are bonding, antibonding, bonding, antibonding. But since only 1 electron is present in atomic orbital of lithium, so only half of the band, okay, half of the band will be filled and half of the band will be unoccupied. So we will write, I am going to rub this. Okay, so we will write since 2s of Li atom have only 1 electron present in it, therefore in the band formed due to combination of n atomic orbitals of lithium atom. Okay, since 2s1 of lithium atom have only 1 electron present in it, therefore in the band formed due to combination of n atomic orbitals of lithium atom, okay, will contain or will have only half of the band filled, will have only half of the band filled. Okay, now come to metallic properties, explanation of metallic properties using band theory. So I am going to discuss explanation of explanation of metallic properties using band theory, okay. So first one is electrical conductivity. Okay, suppose we are discussing electrical conductivity of lithium. Okay, so I have told you Lin atom will combine, okay, and the band formed okay, will be like this. And in case of lithium, I told you half of the band will be filled. Okay, so these are filled band or occupied band. And half of the band will be unoccupied. Okay, getting this? Means electrons are present up to half of the band. Okay, so here electrons are present. Getting this? So as you will apply electric current, what will happen? Since this is unoccupied, means this is empty, means no electron is present here. So as you will apply electric current, what will happen? These electrons will get some extra energy and will jump to unoccupied band. Okay, and in this way what will happen? Movement of electron will start, and this lithium molecule, Lin molecule, will be conducting in nature. Getting this? Take one more example. Take example of beryllium. So beryllium is 4. So it is 1s2, 2s2. Okay, now confusion means we starts confusing. Okay, sir, beryllium have 2 electrons present in 2s orbital. So if 2 electrons are present in 2s orbital, means these means in band, okay, all of the band will be occupied. Okay, then according to this Be, beryllium, okay, should be insulator, an insulator. Getting me or not? Because in its 2s, 2 electrons are present. So what will happen in this case of Ben molecule? In the case of Ben molecule, all of the levels of the band will be occupied by electrons. So there will be no space for the electrons to move. So how could it be a conductor? Okay, so what happens is this case, it is 1s, 2s, and in class 11th you have studied, if it is 2s, then it have also 2p, and here 2p is 0, means in 2p no electrons are present. But you have studied the energy difference between 2s and 2p is very less energy difference. Okay, so what happens? This 2p orbital, okay, since this 2p is vacant, so what happens? Electrons from 2s jumps to 2p orbital like this. This is 2s electron, and 2 electrons are present in 2s, okay, and 2p is empty. Okay, but I told you energy difference between 2s and 2p is small. So what happened, this 2s electron will jump into 2p. Okay, and what will happen, electrons will start moving, start flowing, means this will become a good conductor. Okay, and in this way Be beryllium is a very good conductor as compared to lithium. Okay, so there is two concepts. One is called, means the bands are of two types. Now we will discussing bands are of two types. One is called valence band, one is called valence band, and other is called conduction band. Okay, for example, here 2s. Okay, this 2s is valence bond. Here 2s is valence bond. You will get you will simply understand this. This is valence band here. And this 2p is conduction band here. Is conduction band here. Means what? Band are of two types, valence band and conduction band, and just I am going to define these bands. It is valence band and valence band are those band in which electrons are present. Electrons are present. Okay, conduction band are those band in which electrons are not present. In which electrons are not present, and which helps in conducting by accepting electron from the valence band. Okay, getting this? I told you what is valence band. Valence band is the band where electrons are present. Very simple to remember. Those band in which electrons are present. So valence band is very simple. Okay, here this is I told you 2s2 is valence band. Why? Because electrons are present, so valence band I told you. Then conduction band, those band in which electrons are not present. Come here, electrons are not present. Okay, and which helps in conducting. This beryllium was conductor due to the presence of this 2p orbital. Okay, so and which helps in conducting by accepting electron from the valence band. And I told you one electron is jumping and coming to this 2p, which I told you conduction band, and since it helps in conductions, so it is known as conducting or conduction band. So two types of band are there, valence band and conduction band. Okay, now in next lecture we will be discussing about semiconductors. Okay, thank you.